Good afternoon and welcome to today's Roads and Bridges webinar titled Advance Your Infrastructure Projects with Digital Project Delivery, sponsored by ALLPLAN. I'm Gavin Jenkins, Senior Managing Editor with Roads and Bridges at Endeavor Business Media. To begin, let me explain how you can participate in today's presentation. First, if you have any technical difficulties during today's session, please put your question in the questions window and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser as they can cause issues with the webinar player. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation. But please feel free to send your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the submit button. Also, please be aware that today's session is being recorded and will be available on the Roads and Bridges website within the next 24 hours. You'll be notified by email when the archive is available. Now, let's turn it over to ALLPLAN's team for today's presentation. Take it away, David.
Good afternoon, everybody, and welcome to Advance Your Infrastructure Projects with Digital Project Delivery. My name is David Lockery. As I'm sure many of our audience knows, I am our business development lead for infrastructure and public markets here in North America. I have with me Jalpesh Patel, a senior technical consultant and BD lead, and Alex Barbone, our new infrastructure lead technical consultant. All right, so to get this show on the road, we're going to be discussing today what is digital delivery and why, and also, perhaps more importantly, how. So as I'm sure many of you know, digital delivery is one of the new hot topics for project owners and also consultants and construction contractors here in the US. We have quite a number of DOTs, DPWs, port authorities looking at how best to prep our deliverables for the challenges that are coming down the pipeline in the next half century. Just like CAD equipped us a little better to meet the challenges of the last half century. And one of the things that we see frequently in discussion with these various stakeholders is that transportation project delivery here in the States is at a crossroads. Obviously, there's more attention and more funding than was the case even as late as a few years ago. But nonetheless, there are a number of major challenges coming. Compared to when we started delivering in CAD, our transportation infrastructure is much older, not just in the more established states in the Northeast, the upper Midwest, but also now in the South. States like Arizona and Texas and Florida have a great number of bridges that were built in the post-war era and are now reaching the end or edging towards the end of their originally designed lifespan. And as we grapple with those challenges, we're looking quite a bit at retrofit, life extension work, but also a greatly increased number of just outright replacements. And that brings us to the need to minimize user disruption. All of this infrastructure is being heavily utilized, in many instances far beyond the utilization predicted or designed when it was initially built. So we're looking at a great number of instances where we have greatly compressed project timelines in order to facilitate replacing major assets that perhaps even hundreds of thousands of people use daily. To meet that need, we're looking at quite a bit of innovative construction methodologies and innovative contracting methodologies to speed these timelines. A greater prevalence of P3 and design build projects, and on the construction side, a greater reliance on prefabrication and accelerated bridge construction. The flip side of this, of course, is that these methods are being employed in increasingly crowded conditions, both the population having grown considerably and the existing infrastructure around these bridges that may need to be replaced having grown considerably. So utility conflicts and other infrastructure conflicts, as well as impinging on a great many number of neighbors, is a serious concern. All of this brings heightened project risk. Talking with the stakeholders that we deal with regularly, many of them are highlighting the need to control cost and schedule more stringently than ever before. We have recently invested a good sum of money into the job of getting a lot of our infrastructure and replacing the most aged bits of it. Nonetheless, there's also a lot more infrastructure out there over the next 40 years to be replaced. That, again, brings increased complexity of design and construction to meet the needs of ABC, prefabrication, tighter fit-up requirements, more automation both in the field and in the shop. And all of this is really intended to allow us to increase worker productivity, both on the design side as well as once we get to construction and fabrication, and even going into the future. Better optimizing our allocation of resources for maintenance, for asset management, for inspections. That in turn means that when we're working on these crowded locations, using more automation, using more prefabrication for more complex designs on a smaller footprint, we have a much increased need for coordination and change management, better data exchange, and also better data longevity. How many people have worked on a project where the as-built is a set of scanned, hand-drawn documents from 1955, where everything is illegible, the scan quality is terrible, and we can barely parse out what's there now. To meet all of these challenges, a great many DOTs, AASHTO, various other port authorities and project owners have been looking to BIM technology. It's been reasonably well exploited in the vertical sector and industrial structures, but until recently, it's never had a serious look from the linear infrastructure side. Now we have 24 DOTs, and I think this map is actually a bit out of date. I think there are a few more at this point, but at least 24 DOTs looking seriously at how can we develop non-proprietary, easily shared standards for exchanging digital information, by which we mean not just BIM models, but also a great deal of metadata, a great deal of fabrication and construction information, and all of the 4D aspects that come with construction. So that project has been ongoing for some years now, and is really starting to come to fruition in the form of IFC 4.3. Touch a little bit on IFC 4.3 because that's going to be threaded throughout the rest of this presentation. IFC 4.3, IFC being industry foundation class, is a neutral and non-proprietary data format intended to facilitate project delivery in open BIM and open 2D open data formats. It's intended as a way of allowing DOTs and EORs to work in almost any tool from almost any vendor, pick the best tools for the job on a given project, and still collaborate with one another, communicate with one another, and ultimately deliver into a common file format. This schema, this IFC schema, has been greatly developed for buildings. AASHTO is working with Building Smart and the DOTs to extend that schema to the modeling of bridges to start, and ultimately then from there into future schemas that will include things like roadway, rail, and tunnel. And at this point, I'll turn it over to my colleague Jalpesh, who's going to discuss what digital delivery is from the engineer's perspective. Jalpesh?
Thanks, David. Yes, in terms of digital delivery, David quickly went over in terms of why now and ways to get there. So what I want to cover is how our customers today are using digital delivery, using the tools that are currently available on the market. The first thing that comes up when you talk about digital delivery for majority of the people is 3D model. Well, that is correct. It doesn't necessarily have to be a 3D model. It's a 3D BIM model. And a BIM model is slightly different than a 3D model. In terms of a BIM model has the I in the building information model, where I is the key component, the information that is part of the model. That is what helps it make it digital and then be consumable in different various ways. So when you create a 3D model, some things that you need to be mindful of is the level of information that you're going to include in it, the level of detail that needs to take place in the model, and also the data structure, because we want the data structure to be organized in a way where the end receiver of the design can consume the model in a format that they're comfortable with. So how do we do that? Again, a 3D model is a good starting point where you could put the geometry in a 3D format, but it doesn't necessarily always have to be in 3D 100%. We could combine it with a little bit of 2D design as well, or we could do the whole thing in 2D design. Some examples here are, we have a 2D detail that we are all familiar with. These can be any standard details that a DOT might have specified. And what we can do is we could attach information to it. So in this specific case, we have attached an attribute criteria where we include a range for the toe wall height. This helps us control the design and also control the limitations of that detail. And that information is crucial here for that digital delivery, because we are not only controlling the quality of the design, but we're also storing that data in a digital format that can be validated on the go during design process. But later down the road, we can extract that information when needed and necessary for different tasks. Once you do have the 3D model, the benefits of a 3D model or a 3D BIM model is that the visualization that can be generated for it. So having that third dimension puts a whole new twist to the design, where you could use that data in multiple formats in different ways than you would be able to if it was just 2D. The reason for that is the 3D component makes it so realistic that we could kind of integrate with other platforms that project teams are already including within their design process. Perfect example here is the design team is modeling the bridge and coming up with the layout and the design on the right-hand side in ALLPLAN, where they're mainly focused on the layout of the bridge, and they are focused on the material properties of it. The design is also mainly focused on the detailing and the structural stability. At the same time, we have other aspects of design that play into the overall project delivery. And one of the main things that come into play here is doing renderings and visualizations for community engagement to make sure the client understands what they're receiving, and also the community is on board in terms of the final product. And what we do many times here is create 3D renderings. So the key thing here is that if we could utilize that same model to do those renderings, then we kind of want to do that as much as possible, because that helps us improve efficiency and also improves accuracy.
I think that's a theme that's been threaded through almost all the conversations we've had with folks in the industry. We do all of these things anyway, we just do them separately and at great expense.
Exactly. And right here is another quick example of that same process. We usually go through a design process, we create our design plans, and then we sign them off, and then we send it off to the contractor, where the contractor will coordinate that design with the manufacturers for the components that are needed for construction. Well, if we were to define all that design digitally in terms of a 3D model or a 2D detail with attribute data, which is relevant for those components, we could reuse them except having to regenerate that information. So in this example, we were able to take the 3D model, and then the 3D model had a detailed model of the reinforcement, which included attribute data in terms of rebar shapes, type, all the necessary information that is needed to generate that reinforcement or manufacture it through a bar bending machine. What we were able to do is, because the information was available digitally and not in a paper format, we were able to manipulate it into a format that a rebar bending machine can understand. So again, that data flow was maintained, where we took the 3D model directly through ALLPLAN, create an output file, which is understandable by the bar bending machine. So at the end of the day, what we're seeing in 3D virtually is what we're producing, and we have kind of validated that design in 3D because we had that third dimension and basically did a virtual construction of that element. Which brings us to the next topic, is the review process. The benefit of a digital model is we want to also review it and use the attribute data and the metadata behind the model to make educated assumptions, as well as define construction elements in a way that the design is constructible. So in that process, we go through a lot of different variations in terms of how we review that design. Different components of the bridges are reviewed by different parties in the team. So sometimes all the information that is plopped onto a sheet might not be relevant for them. Well, the benefit here is if you have a digital model and attributes associated with those models, you could quickly filter it and create views which are relevant for the reviewer. So in this case, the main focus was just tendon geometry review, and they were able to just go down to the tendon geometry and then hide the other components and kind of see how that geometry interacted with the other parts of the bridge. Additionally, you're able to turn on those components, like the example here where we had the reinforcement turned on, where we could kind of see the coordination between the reinforcement detailing and the tendon geometry. And the benefit here is you could see on the left-hand side, we have access to multiple ways of consuming this data. And the way we could consume this data is different filtering methods. So in this model, the reinforcement has been segmented into different layers, and we could turn those layers on according to that placement. This helps us understand how that placement is going to take place in the field and the conflicts that it might entail with the current design. The additional benefit that you could get with this data structure is that we could share the same information in the field, and the field engineers and the contractor can see the sequence these reinforcements need to be installed in. And if there are some conflicts, they could be aware of it ahead of time. That way they could contact back to the design team and get validation and verifications in terms of the intent of the design. So again, Over here, you have that flexibility of consuming that information in a manner that you're used to, or you could create customized workflows from that digital data in a way that is relevant for your field or your segment. A quick example here, they're using that same model. Again, what we were seeing earlier was a BIM Plus platform, which is available online. And the key benefit of the BIM Plus platform is that because it's a URL-based platform, it is accessible anywhere in the world. So the contractor in the field, the designer in the office, all have access to this model in a centralized location, and they could share information and collaborate as needed. And this helps out in the construction site, making sure that transfer of data from the office to the site is streamlined and it's accurately available when needed. So far, all the examples we looked at, and when we talk about digital delivery, people have an assumption that all of this is implementable only in new construction. Well, that's not the case. We could also do that with existing structures. So different formats of digital information is a point cloud or a LiDAR scan. So in this example, we were able to do a LiDAR scan of an existing structure that had to be modeled within our BIM environment. That way, we could kind of do some coordination of modifications on the existing structure. This will be the same example if you were to model as-built for existing structure, if you wanted to do, let's say, a deck widening or had some rehab that needed to take place. What we can do is first do a LiDAR scan, which provides our survey data and the geolocation of all the different components that make up the structure. And then with our partners at Celesco, we were able to coordinate the placements of these elements in the 3D geolocation and build a digital twin almost within ALLPLAN. So you are able to select elements within the point cloud to place your elements, and then 3D model was generated in ALLPLAN. Similarly to what we saw with the visualization, where we had ALLPLAN on the right-hand side and Lumion on the left-hand side, and we were able to integrate seamlessly.
Amusingly, I was just having a conversation about this yesterday, and I was under the impression that we didn't have a good workflow for it. So back to the customer.
So what we want to do here is we want to make sure that we understand the true meaning of digital delivery. Yes, 3D has a big component, the BIM aspect of it, but there are multiple formats that this can be achieved. And a good example here is a recent pilot project we're about to wrap up with our partners at Pannoni and DelDOT, is this project 447 over Taylor's Bridge Road. And the great thing I like about this is that their focus was all digital delivery and how far can we take it. And this also didn't have a specified that it had to be done in a single platform, or it was like, how can we use the best tools available on the market and tools that the teams are comfortable with and exchange data in an open format. So over here, we have a quick example of, we have on the left-hand side, open roads. On the right-hand side, we have ALLPLAN bridge. And the team was able to coordinate the two models seamlessly with each other with the open data format through IFC. And additionally, information that was not possible to transfer through IFC, we were able to do through a native format that ALLPLAN was able to generate a 3D DGN. And the great thing here is that we could do some volumetric checks over here. They have an existing bridge in place, so they were able to produce volumetric clash detection against an existing structure and to make sure that layout was sufficient for constructability reasons in terms of clearances from existing structures. So the workflow here was they had a project alignment that was generated in open roads because that's the tool of preference and they're happy with it, which is great. And we were able to bring in that information directly into ALLPLAN and create that integration. Once that alignment data was available within ALLPLAN Bridge, they were able to create a parametric bridge model and create a couple scenarios. And the reason for that is that because the bridge was fully parametric, they were able to go through different iterations fairly quick. Once they went through the different iterations, they were able to pass on each iteration back into open roads to make sure the clashes were not occurring and the design was sufficient for their needs. The open format of IFC and then a native file format of DWG, both which can be exported from ALLPLAN, played a big role in that collaboration effort of using multiple platforms of preference and still having the ability to streamline the data exchange workflow. Further, we were able to take that BIM model, again, it was just not a pretty 3D model, it was actually an intelligent 3D model where the detailing was also done in a sophisticated manner where a lot of attribute data was associated with those elements. When we create plan sheets, we have a bunch of notes that come into play. That same notes can be applied to an attribute set within ALLPLAN. And the benefit of that is that the attribute data can drive some of the production, the 2D production that is still necessary in today's world. In this scenario, we were able to automatically generate our quantity tables, our rebar schedules from the 3D model and the attribute data that was associated with it. That streamline of information, making sure that the information is flowing smoothly from one process to another. And then you truly have a centralized model. And over here, it's not only within ALLPLAN that you could consume this information, you could actually export it to other formats like Excel or Word to create customized reporting as necessary. And then, of course, the 2D plan set. I mean, plan sets are here to stay. The whole industry is accustomed to this process. There's going to be portions of the process in your digital delivery that will have to be accomplished in 2D. So we want to make sure we have that functionality part of that workflow. Yes, we have ambitious goals of going total 100% 3D, but it's still time before we get there. So again, we kind of keep that in mind. Digital delivery does not mean a 3D model. It means a way of providing the design intent in a manner that the information can be consumed by the receiver in a way they're accustomed to. So it could be 2D, it could be a 3D model, it could be a rendering, it could be a 3D PDF. And all of that is possible when you have a data-rich BIM model, which we have in this case, where we were able to take that centralized 3D model, create our reporting in tables, as well as these sheets that we see right here. And the benefit here is a lot of these texts and labels that we're seeing in the plan sheets were automatically derived from that attribute data, along with these tables. So you could pull northing and easting elevations, true elevations from the model, and that way you have a realistic virtual model of the design available to you. And you could start reducing risk and get the deliverables that are necessary at the same time. So you're not adding work on top of it where you're doing a 3D model at the same time you have to do a parallel 2D workflow. No. We have a 3D workflow where the plans are the byproduct of that 3D workflow, and we're not generating them on the side, which is the true power that you get from a digital design, because that data is available digitally, and then we can generate any output that we want in a format that we need. And then we had the renderings and the public engagement. And this was pretty impressive because, again, the power of open BIM and different non-proprietary file formats that they could share or proprietary file formats makes it a key differentiator in terms of what the ALLPLAN workflow can provide. In this scenario, the design team was able to take that 3D model from the ALLPLAN environment and push it into their 3D visualization platform that they have in-house and showcase the design intent and the final product to the community ahead of time. And this is all possible because they were doing the design digitally, and they had that information available in a format that they could quickly manipulate and consume into a different platform as necessary. To get more into what the ALLPLAN environment is, we're actually going to do a quick webinar coming up in the near future where we'll walk through this workflow. But I kind of wanted to give you an idea that there are multiple options of going in and out of a workflow, which is what makes digital delivery powerful. That data can come into different platforms and leave the platform when needed for a specific task. In our scenario, we have 3 core platforms, BIM plus, ALLPLAN, and ALLPLAN Bridge, which are all integrated within each other. And then during the design phase, that we could take that data back out of this environment into a different workflow. Cover more on that. We have our colleague Alex, who's going to walk through a typical workflow that we would use for digital delivery. A quick example in terms of how to deliver through IFC. And let me pass it on to Alex.
So if you're not already submitting deliverables as IFC models, then producing an IFC model will probably seem a little daunting. Thankfully, with ALLPLAN Bridge, we're working to make sure that the process of creating an IFC model in more digital deliverables is as seamless as possible, and to a large extent occurs naturally throughout the modeling process. Even from the start, every time you start a new ALLPLAN Bridge project, one of the first things it asks you after where to save the project is what the IFC bridge type is. So you can choose from a list of selections here, choose not defined, or even your own user defined. And you'll see these drop downs a lot throughout the process. Of course, even if you started your model and you didn't include this to begin with, you can always change it simply by coming here to the options and project settings. Besides all these values that are associated with units you're using, down at the bottom here, you'll see an opportunity to, again, specify or change the IFC bridge type. So you'll see the opportunities to enter the IFC entity values throughout the modeling process. For instance, every time I come and create a new structural unit in a cross-section, I have the opportunity to specify what the IFC entity value is. So let me just select one of these beam values. And we can see in the properties over here, I have an opportunity to enter the IFC type and the IFC name. Again, we'll notice that these include a large variety of built-in options. You'll notice for a lot of these, there's a user-defined option. It's not immediate obvious, but you can actually edit all of these values. These just plug in a string of text that you can edit. So if you want to choose an option that is not included in this list, you are free to enter your own values. I do want to change this one back to beam, however. So you'll see these show up again when you start the project as you're creating your cross sections, and you'll see them when you create structural members as well. Let me come back here to the 3D model. And we'll select, for instance, these steel girders. So you can see here, come to the properties. Again, I have the opportunity in this case to enter the entity value for the IFC bridge part type. And again, we try to make this process as easy as possible and make suggestions to you along the way for what are appropriate values. So you can see these are showing up just in the properties palette as I'm selecting objects. They'll show up throughout the modeling process simply by interacting with the objects. And it's not like I have to go to a hidden menu somewhere and specify all of the IFC values at once. I don't have to create a configuration file. I can just plug in the values as I normally go about the modeling process. And that's especially helpful for engineers and designers who aren't experts in the IFC data schemas. Just follow the prompts on screen. It's really that simple. And if you're breaking up who's working on which parts of the model, then you also have the opportunity to have the people creating those objects choose the appropriate IFC values. So you can easily divvy up the work rather than waiting until, say, the end of your modeling process where you have to go through and start entering these values. You can just do it along the way. And that's not the only way we're using IFC values. Actually, we have a new feature here in ALLPLAN that we're referring to as attribute sets. So this is a really interesting functionality because what we can do here is automatically assign some attributes depending on what sort of IFC object a ALLPLAN object is assigned to. So let's take, for instance, this girder right here. I can see there's already a collection of attributes assigned to this girder. One of them you'll notice is this IFC object type. So in this project, I am using attribute sets. So if I were to come here and change my IFC object type from undefined, which is just a default value, to IFC beam, we'll notice that this building element proxy common, this group of attributes up at the top, will change. I'm going to press enter, accept the values. And when I look at the object again, you'll notice that I have a category. It was replaced with beam common, and I have now a whole list of new attributes. Some of these might be the same because they're fairly common, but I can see, for instance, that I have this property, or this attribute, I should say, called unit weights, and the value is 0. I can also see that there are some other attributes here, major bridge assembly and national bridge element, that aren't correct either. But now I can be more aware of them simply by adjusting the IFC object type, and then the attributes are selected. So now I can come in here, and this one should be superstructure. And then this value should be a girder beam made of steel. The unit weight of steel, we'll say 490 pounds per cubic foot. Now we can see even my weight is being calculated correctly. So all of that stuff became really obvious just because I'm using this attribute sets. I already configured them the way I need to for this demonstration, and by changing the object type, I now am prompted to notice that there's a few attributes that maybe weren't populated correctly. So it could have been extra work for me to go through and specify all of these IFC object types to make sure that my IFC model is being generated correctly. But that's not really the case here. This is now part of my quality assurance process. I know that this is just the thing that we do to make sure that we have the correct attributes loaded. Now, these attribute sets are configured either on a project-to-project basis, or you can create one to share between projects. So I can come view the properties for this specific project, and I can see that what I'm using here is the Office standard. So this is just the default one for my organization. I can also create project-specific ones. I can use some of these default ones, the IFC common. I can also just turn the feature off altogether by selecting none. And I have the option as well as importing from BIM+. So this is extra helpful for situations when you have people that are going to be setting up this process. They don't even have to have ALLPLAN open. They can actually manage the whole attribute set process directly in BIM+, and then it can be loaded into ALLPLAN for the modelers that are working in ALLPLAN to specify these values. So you can manage all of this information and set up this quality assurance process outside of ALLPLAN and import that information in. I'm going to keep that at the default here and close out of these menus. And then we'll take a look at, since we're talking about quality, some features for quality control in ALLPLAN engineering. So we know that, especially for engineers, you have to have a way of performing quality control on a BIM deliverable. And we also know that engineers love their spreadsheets. Thankfully, there is a way in ALLPLAN engineering to simply export attribute information to an Excel spreadsheet. So I can start the export attributes command, and I can see here I've got plenty of settings. One of the most important ones is this report template. There's obviously a lot of data involved in this model, and I probably don't want just an enormous list of everything that's applied to this project. This report template gives me the option of selecting which attributes I want to export, and then the on-screen prompts will allow me to select a certain range. The report templates, there's a lot to choose from. There's plenty of defaults here. I've also created some of my own, and these are very simple text-based files. So for instance, if I were to open up the one that I'm using for this example, it's just an XML expression. We can see that, there's a bunch of control lines here and there, but really the only thing that's important is this list of attributes in the middle. The syntax is the same for all these RDLC files during this process. So you can easily come in here and just enter the attribute numbers that you want to export and then what the name of those values are. Just close this and return to ALLPLAN. And what I'm going to do is just indicate that I want to export this information to Excel and then start Excel immediately. I'll just select all the data. ALLPLAN will immediately export that information to Microsoft Excel, and now I can easily browse through the spreadsheet and take a look at the attribute values that were assigned to the objects that were selected. So now I can get that information easily out of ALLPLAN, but I can also send it back in. So one nice feature about this process is if I notice that there are any mistakes in the attribute information, I don't have to go back to ALLPLAN to change it. I can do that right here. All I have to do is edit the file and import the information back into ALLPLAN. So for instance, I can see that I've got these objects on my drawing file that I know includes only objects for abutment 1, but for some reason they're assigned as a decker slab, and the NBE is indicating that it is a reinforced concrete slab. So I'm just going to copy the correct values from another object in that same drawing file, and we'll overwrite those. Simply save the spreadsheet. We'll close that down. And then we'll press the import attributes command here. I can choose that same Excel file that I created moments ago. I'm also going to check on this with dialog box for comparing data. That lets me then take a look at all of the changes that I'm about to introduce. So this gives me one last check instead of just blindly copying in all that data. Now I can see, for instance, that I am going to be importing this specific information. So I can see the attribute major bridge assembly is going to change from deck to slab to superstructure. And I have the option of choosing whether or not I actually want to import that information. So in this case, I know that I want to import all this information, so I can just press OK. The process will unfold, and now my attributes are correct. So this is a nice process because it lets me take data in and out of ALLPLAN. We saw that a few times just in these few minutes, that information can be brought to other programs and applications. And that really lets me, as an engineer or designer, choose the best or maybe even the most comfortable tool for whatever task is at hand. I'm not restricted to working exclusively within ALLPLAN. The point is to have an open environment where we can exchange information fluidly. And of course, we are realistic here. Not everyone is going to be ready to accept an IFC model as the only deliverable for an infrastructure project. There are plenty of agencies out there that are still requiring that 2D deliverables be included at the end of a project. Of course, ALLPLAN provides you the functionality to create those 2D plan sets. So just taking a look at a few section cuts that were created from the model that we've been looking at. So I can easily create drawing sheets within ALLPLAN and then export those to a variety of formats. So I can export and print these, for instance, to PDF and have a full PDF set that I create from my BIM model if a 2D deliverable is necessary. And more advanced deliverables might also be necessary, such as 3D PDFs, also a functionality that we have in ALLPLAN. So I can't promise that every PDF viewer will be able to open and view a 3D PDF and allow you to navigate in Zoom. But it is an option to create 3D PDFs. Just make sure you've got a viewer that can handle that sort of file extension. Of course, sometimes we need to export even the plan set to a variety of different formats. So for instance, maybe an agency is requiring that they be produced in DWG or DGN. We have that functionality as well. And we actually have the option with this command here, the ALLPLAN exchange layout distribution. I know that's a mouthful, but what it does is pretty robust, and it will allow me to set up an export that sends this information to a variety of different file extensions. So what I can do is choose which of my layouts, so those are my different plan sheets essentially, and choose which formats that these will be exported to. And I can choose multiple, so I can export the same layouts to PDF, DGN, and DWG at the same time. So select here, and I can see that there's even some options that I hadn't selected. I can also specify what my exchange favorite is. So this basically maps information from ALLPLAN system to whatever system that you are exporting to. So for instance, an exchange favorite might remap ALLPLAN layers to microstation levels. So that way I can set up that configuration once and then be assured that every time a drafter or modeler runs this export, as long as they choose that exchange favorite, they'll be able to export that information accurately and create a deliverable that looks indifferent from one that was created natively within, say, MicroStation. I can see here that there's also a variety of exchange favorites to choose from. Throughout ALLPLAN, you'll also see options for saving and loading favorites. So at the beginning of a project, or maybe the first deliverable, the 10 or 30%, I have the option of coming in here, setting this up, saving that favorites, and then allowing another individual to recall that favorite later on and produce a more recent version of what is otherwise the same deliverable set. For agencies and consultants that are ready to start using IFC, it is a simple process to export an ALLPLAN engineering project to IFC. So we have a specific command, export IFC data. Once you start it, the first thing it asks you is, well, which parts of your project would you like to export? So again, option of selecting whole or even just parts of it. You might want to break up IFC models for one reason or another. Maybe you just need to isolate them, for instance, based off of specific design discipline. I'm going to select all of them in this case. And then I have a menu, and the first two things it's just going to ask me is, well, where do you want to save the IFC file, and then what exchange profile. So in this case, the defaults are the different IFC standards. I can expand my settings as well. And when I do that, I have a lot more options here, and I can get pretty granular. But again, notice that whenever I'm done making these changes, I can always save this as a favorites and then recall those later on. So it's important to us to make sure that if you've already gone through a process once of setting things up just the way you like them, make sure that you can save it and then use it again later. That way you don't have to keep redoing the same tasks. Once the IFC model is created, you can go ahead and bring that into, for instance, your favorite IFC viewer. So switching over to another application here, I can see that this was the IFC model that was created from my ALLPLAN model. So now it can be freely exchanged with any individuals that have an IFC viewer, and there's a decent amount out there that are no cost to low cost. Some of them just have simple features and only allow basic options such as measuring or querying some of the data here. So you can see though that I can select the objects within the model and then view their various properties and some of the attribute information that has been brought over from ALLPLAN. So for instance, I can see this material was specified when this object was created in ALLPLAN brige, and it becomes obvious at the end when I have created my IFC model. Now let's take a look at BIM+, which is ALLPLAN's cloud-based platform. As a cloud-based platform, it's accessible via the internet, and it doesn't require the installation of any software in order to access and use. The benefit of this is that you can collaborate with users outside of your office or even your organization. So you're able to invite what we call external users to your project or to your entire BIM+ team, and then you can calibrate the permissions that they might need to have for either the entire team or even just a specific project. So you do have that level of control. The model that we're looking at right now has been created in ALLPLAN and exported directly to BIM+ from ALLPLAN. But we can actually import IFC models from any source. So This isn't exclusively for modeled information that has been generated in the ALLPLAN environment. If you can export it to IFC, you'll be able to import it into BIM Plus and view it alongside your other models. So if you have a design team that is producing a variety of different BIM models from different locations, maybe they are different offices or just different companies altogether, you're able to export your IFC models, place them all in BIM Plus, and then see the geometry side by side. So you can use this as a centralized location for your modeled information. But it's not just your modeled information. We do have the ability to import all sorts of file types and documentation. So you can also use BIM Plus to share all that information between your design team colleagues, again, regardless of what company they work for or where they work for. And it is more than simply a model viewer. I am actually able to interact in meaningful ways with the contents of any of the models that have been uploaded to BIM Plus. If, for instance, I were to select this steel girder, of course, I'd be able to view the individual properties of that girder, but I can actually make changes to it. So I can update an IFC model. Maybe there were some properties that were missing when the model was previously created, or maybe some of them were entered incorrectly initially. I can correct them here before passing along this information to either my client or other members of the design team. I can also add comments to individual pieces. So if there's some sort of information that doesn't fit within any of the attributes or entities, then I'm able to freely enter text as well. The other features that we have here are attaching documents. So maybe I have, for instance, a shop ticket that I've received that is related to this steel member, or maybe it's an RFI. I can attach that document to this piece, and now if anyone is interested in finding related information about this object, they can simply select the object within BIM Plus and then see related documents. If I've got a location to another web resource, so maybe I've got a online repository that links to, say, construction photographs, I'd be able to add links to that resource simply by attaching a URL. And if I've already gone through the process of uploading a lot of my design or operation documentation, I can also attach that too. So the difference between these two options is this option goes and attaches a file that maybe is on my local computer, whereas this option will attach a document that is already hosted within my BIM Plus project. The feature that we're most interested in sharing with you today is the issue manager. So we know that engineers need tools to review their designs. And a lot of the times it's necessary to formally document that process. I'm sure you're all familiar with the ways your various organizations have developed a procedure for completing the review process and ensuring that you've got adequate documentation for that process that you can share with maybe your customer to show that you are practicing a rigorous quality control process. Obviously, we need something similar for digital delivery. So that's where the issue manager comes into play. We're able to create a similar workflow, and maybe in some cases it's a little more streamlined. For instance, as we'll see with the issue manager, communication has been streamlined, immediately alerting the responsible individuals that there is an issue that has been identified. And the other benefit, as we'll see, is that we can collapse the schedule. With a more traditional CAD delivery, a lot of the times in the review process, you've got one segment of the process that is just dedicated to the engineers or other subject matter experts reviewing the design, where it stands at that particular moment. And then after they have created all of their comments and documented their concerns, then it gets turned over to the CAD technicians or modelers in order to address those changes. The issue manager allows us to collapse that and have the individuals responsible for correcting those issues work while individuals are still completing the review. So one of the benefits of this BIM process is that we can collapse that schedule and complete the whole process sooner by doing some actions in parallel. So let's take a look now at one very simple example that we can create using the issue manager. It's available here on the left-hand side. And what I can do here is I can simply select one of the objects in my model, and then I'm going to create a new issue. The issue is going to be related to a specific property that has been misentered. So in this case, what I'm going to look at here is this NBE, National Bridge element, has been misattributed. This is indicating that it is a reinforced pier wall rather than a footing. So in this case, it seems that the modeler had selected the entirety of the pier object and then assigned it to the same NBE number, but in reality, we actually want that to be a little more precise for this footing element. So with that element selected, I can create a new issue. I'll give it the name, wrong NBE assignment, and then I can type in a description. Should be I can set a priority for this issue, and then a status of open is automatically assigned to indicate that it was just created. Here, I'm able to assign a responsible individual, so this is choosing me as default, probably based on alphabetical order. I can choose additional people as well to be viewers on the issue so that they can track its progress. I also have the option of choosing things such as who it should email about this issue, establishing a due date, indicating a type, and other tags. So these might be helpful for organizing issues if you have a lot of them. So what I'm going to do here is, just with these few simple things entered, I'm going to press the Publish button. That Publish button will then create the issue within my list of all issues, and now we'll be able to keep track of it. Now let's see how the process continues from the point of view of a modeler who has been made responsible for addressing some issue. While I'm working with an ALLPLAN, I can access all of the issues that have been generated in BIM Plus through the Issue Manager palettes. I can also add in additional issues from here. So if I do have some reviewers or engineers that are working directly within ALLPLAN, they're able to add their issues here, and all of those become available within BIM Plus as well. I can see that I have already been made responsible for an issue, that wrong NBE number issue that we had created just a few moments ago. From within ALLPLAN, I am able to view all of the information related to that issue, and I can even see that the object has been identified on screen for me. So I can read a description of the issue and view any of that other similar information that we had seen within BIM Plus. That makes it very easy to select the object that has been identified. And in this case, I'm going to come over here into the properties for that object, and then correct the NBE value here. In this case, changing it to identify it as a pile cap / footing. With that done, I can return to the Issue Manager and indicate that the status of the issue has been solved. And then save that change, which should be synchronized back within BIM Plus in just a moment. This allows my reviewer to automatically communicate to me by assigning me as the responsible person, and for me to communicate back simply by updating the status and setting that to solved. Now let's return to BIM Plus and view the issue. So from the perspective of the reviewer working within BIM Plus, I can come in here and take a look at my issues to see whether or not they've been addressed. And in this case, I can see that this specific issue has been set to solved. I'm not limited to viewing the issues one by one. I can select the issues out of my list, maybe all of them or just a selection of them, and then view them in a tabular format. This can make it easy to check on the overall status of a whole list of issues. This table can also be exported to Excel, so this could be helpful if you need to have some sort of easy documentation to indicate that you have completed a QC review, maybe during a particular deliverable milestone. So say at 60%, you can go ahead and export all of the issues that you've created for the whole project so that your client can be comfortable knowing that you have completed your review process and they are receiving a quality deliverable from you. So you can see that this Issue Manager is a relatively simple tool, but it addresses a lot of the needs of a review process. It allows people to add their issues regardless of where they're working, BIM Plus or ALLPLAN. It allows the people made responsible for those to see that they've been made responsible, and it really cuts out a lot of the communication. And by addressing the issues in a one-by-one fashion, we're able to collapse the schedule, and instead of requiring that the review be completed in its entirety first, and then all of the corrections made, we can actually run those two tasks within parallel, which saves us more time for other tasks within the design phase.
Okay. A few of you have already submitted questions, so we're going to jump right in. If you'd like to submit a question, type your question into the question window on the side of your screen and hit the submit button. All right, so our first question, can you create public-facing visualizations in ALLPLAN or BIM Plus? David, would you like to start with that?
Yeah, absolutely. Yes, you can. In addition to exporting to several commonly used visualization formats, including SketchUp, we also have an in-house visualization tool based on our parent company's other product, Maxon, that allows for quite a bit of static rendering, even flyovers, lighting renderings, to take place within ALLPLAN itself.
Okay. And to go along with that, can we develop our own tools for BIM Plus?
I could take that one.
Jalpesh?
Yes, you can. So within BIM Plus, there is an open API. We actually have partners that are working with us to connect their products within BIM Plus. So it's a totally open environment like we discussed. The key thing here is we want to get as many coordinations taking place in BIM Plus and create a centralized location where all the data can be found in a central model. So yes, you could create an open API connection to BIM Plus and bring in any data you want, and then we could kind of work with you if you have additional questions in terms of how to get that going.
Okay, all right. Now this question is a long one. It comes from Benjamin Jilk from the Minnesota DOT, and so bear with me as I read it. You mentioned taking section cuts and showing in 2D. As an example, say you have a deck on a skewed bridge with reinforcement parallel to the skew. If you want to take a longitudinal cut of the deck to dimension the reinforcement, will the 2D plan automatically show the rebar as dots, or will it be a mess because the rebar is skewed? And you'd have to manually go in and edit the 2D view to just show the dots. Gentlemen, who would like to take that?
I could take that one. So yes, we can generate the dots automatically, so we don't have to put them manually. Within ALLPLAN, you have multiple ways of representing that. So you could say that you just want to see the interface at the face of the cut. We also can do any shape when you're doing it. So you don't necessarily always have to do a longitudinal cut. You could do diagonal cuts as well. Depending on the need of that detail, you could cut it in either orientation. And then we have multiple view options in terms of how you want to view that cut. So that way you don't see anything behind that cut. So that way you won't see the diagonals, you'll actually see the diameter of that reinforcement. And then you could populate the quantities and dimensioning automatically from that reinforcement in the 2D section cut. I hope I addressed that question in terms of what was asked.
Yeah, no, I think you did. Thank you very much for that question, Benjamin. Minnesota's DOT is really great. We appreciate you listening. All right, next question. How do third parties access BIM Plus?
David, you want to take that one, or I can take that one?
I've got it. Absolutely. So BIM Plus is available in its most basic version as a free product, something that third parties, contractors, even project owners can use to access projects that are being created within ALLPLAN's environment. Really, the only thing that causes it to cost money is the amount of storage space, and that is primarily a function of the people authoring the projects, not those who need to consume them. So in every instance, we've had contractors, project owners, even third-party subcontractors accessing BIM Plus without any cost to themselves.
All right, let's move on to the next one. What data can be brought into BIM Plus from other disciplines and platforms?
Oof. Jalpesh, do you have the latest list?
The list is pretty extensive. Again, with the open API, there's multiple ways you could bring in data and different types of data. Currently, you could bring in everything from terrain data, alignment information. As Alex had pointed out, you could also tag 2D sheets, photos. So it all depends on how all that data fits into your model. But it's fairly flexible in terms of the data that could be brought into the BIM Plus environment.
All right. Next question is, I still can't see how the construction team can use only the 3D model to execute the work using a IFC viewer on the field, assuming they will use only tablets to manipulate the model. That's more of a statement than a question, but do either of you gentlemen have a response?
I could add to that. Yeah, go ahead, David.
Jalpesh, go ahead.
I was going to say for a single example might be the attribute set that you're applying to your elements within BIM Plus. We could filter them. So we could put IDs for components that can automatically give you a quick quantity check. If you want to do element by element basis, you could click on an element and it'll give you all the data associated with that element. So for example, let's say you have an abutment that you want to construct in the field. You could click on the IFC abutment component within BIM Plus, and on the property palette, it'll give you access to 2D sheets. It could even give you access to the model that was used to design that abutment. And then we could also do 2D data in terms of attribute data that is associated with quantities, cost, and scheduling. So it all comes down to how you organize that IFC model. It's pretty flexible in terms of how you want to do it. We do work with a lot of our clients and work through their current workflows and needs in terms of what the client needs are for deliverables, and then you could kind of create a dashboard that aligns with that need. So in the field, it's easy to consume that data. So it'll come down to, you know, different variations of storing that data within the BIM Plus environment.
And to add on to that, I mean, this is very much a policy question that's being kicked around by AASHTO, the DOTs, and other project owners, is how do we want contractors to consume this data? One of the things that has been mooted is perhaps we don't want to simply kick the model over the fence and have them figure it out from there, that the engineers and the DOT will still be responsible for certain detail callouts being delivered in 2D, that rebar quantities and rebar schedules will still be provided. It's very much an evolutionary process here. No one is proposing to simply pull the plug on everything that contractors receive today.
Okay, next question. How would the construction team use only the model in an IFC viewer to execute the work? They need all the quantities in order.
I think this was the same submission as the last question. Same individual, because it seems to be pretty much the same question.
Oh, okay, yeah, it is the same individual. Okay, all right. Next question. Is there an interface to design software based on a 3D model? If yes, what is the design software, and is it accepted by various DOTs?
So I believe we presented on this topic in the past. As regards design and actual analysis calcs for bridges, we're pursuing two avenues. One is building a native design check and analysis platform within ALLPLAN itself. This is a work in progress, let's just say. The other is working with various private sector partners, acknowledged commercial softwares in North America, to build links between ALLPLAN's 3D models to feed into the design process in their platforms. Among the partners we have in this on this side are Larsa 4D, Midas, CSI Brige. So the answer is yes and no, I suppose. Our own software is still somewhat in its infancy, but those of our partners are long established here. Everyone recognizes those names. Most of the folks on this presentation have probably used them.
All right. Well, I'm afraid that we have run out of time. For those questions we didn't have time to answer, we'll be getting back to you via email. And on your screen, you can see David, Jalpesh, and Alex's email addresses. Feel free to shoot them an email if you have any additional questions. That concludes today's presentation. I'm Gavin Jenkins, Senior Managing Editor of Roads and Bridges. And on behalf of Roads and Bridges, I'd like to thank ALLPLAN for sponsoring today's webinar. And of course, all of you for joining us. Have a great rest of your day.